Welcome to our new unit. We're starting with Unit 5 today on functions. This is Lesson 851, Turtle Crossing, Making Sense of Graphs. In this first lesson, we'll make connections between scenarios and the graphs that represent them. I'm assuming you've already worked through the Desmos activity that shows the little turtle walking away from the water and how that corresponds to a graph showing the path of that turtle. So in class, we got a new workbook, and we're on page 4. If you didn't get your new workbook yet, you can go to Schoology and just print out these guided notes from the resources in the assignment listing. I actually thought this was a really fun way to start introducing what are called functions, and we'll be looking at that over the next 4 lessons. But in this lesson, the real goal was just to make connections between scenarios and the graphs that represent them. Between scenarios and the graphs that represent them. Now, I don't have a cool little animation here to go with the turtle whose journey this graph represents, but we'll still go ahead and talk about what all the parts of this graph mean. Here it says, here is the graph of a turtle's journey. And you'll remember in the activity, we had a turtle that was coming out of the water and crossing over the sand into the grass. So we can see that we have a graph here that goes up, then goes down, then goes up again, where the x-axis represents how long the time has been running, and the y-axis represents how far that turtle has crawled from the water. Now I'm going to highlight these in 3 different colors so it's easy to refer to the parts of my turtle's journey. We have this purple part, this pink part that's coming back down, and this green part that climbs back up again. And we're asked to make a connection between this graph and what's really happening in that turtle's animation or that turtle's story. So what story does the graph tell about the turtle's journey? And we can break it up into these 3 different segments. And let me get a purple pen here. And I can say something about this first part and say for 20 seconds, the turtle is moving away from the water. The distance from the water is increasing. So he starts right at the water, 0 feet from the water. And then over many seconds, he gets 1 foot away from the water, 2 foot away from the water, 3 foot, 4 foot, 5 feet away from the water, 6 feet away from the water, until we get to this point right here. Okay. So let's go ahead and start with just this purple part and say for the first 20 seconds, the turtle moves away from the water until he's 6 feet from the water. This coordinate is 20 and 6. For 20 seconds, the turtle walks away from the water. I'm going to stop there for a moment. We'll talk about that 6 feet in this next part. So in the next part, it looks like the turtle is returning to the water. And the time is still passing. I'm going from 20 seconds to 30 seconds. So for the next 10 seconds, the turtle is backing up towards the water. So let me say that. For the pink part, for the next 10 seconds, the turtle backs up towards the water. And if I wanted to be really specific, I could say he was 6 feet away and then returned to 3 feet away. So we have the point 33. And then we'll finish by saying and then at 30 seconds, he started moving away again until he reached a distance of 11 feet. At 30 seconds, the turtle started moving away again, away from the water again. Until he reached a distance of 11 feet. Until he was 11 feet from the water. I'm assuming it was a he. Now we could say an awful lot more about this. Let's see, this turns out to be a terrible number actually. Right there, this is going up by 2.5, so that at 57.5 seconds, he's 11 feet from the water. So this gives us an idea of what's happening with that turtle. You could look at this and picture the animation that was happening. A turtle walking away and then backing up and then continuing on towards the grass. We could get more specific. I know you know a lot about slopes. We could talk about his pace, his feet per second, if we wanted to find that slope. Talk about how a negative slope means he's returning back to the water. But for right now, this is going to make enough sense. Let's just make sure that we can read the graph thoughtfully and accurately. Let's answer these two questions about the graph, remembering that x represents time in seconds and y represents the distance from the water in feet. This first question says, what is the turtle's distance from the water after 40 seconds? Well, seconds is down here. 40 seconds is right here, and I'm just going to draw a line straight up until I hit one of these lines to see my turtle's path. All right, right there. So what's the turtle's distance right there? Let's move across here, make sure we're reading the scale correctly. It looks like it's going up by ones. So it looks like at 40 seconds, our turtle has moved 6 feet. What's the turtle's distance from the water after 40 seconds? 6 feet. Right there. And then let's come from the other direction. When is the turtle's distance from the water 3 feet? So if it's telling me feet, I need to go to this axis first. This is the axis that represents feet. Make sure I'm reading this scale correctly. This is 1 foot, 2 feet, 3 feet. So I'm going to come across, and you know what? It looks like there's 2 different times when that turtle is 3 feet from the water. Once when he's moving away from the water, and then he comes back to that 3 feet when he's backing up. So there's actually 2 different times that it happens. So when is the turtle's distance from the water 3 feet? Well, at 10 seconds, and then again at 30 seconds. And this is when he's moving away from the water. And this is the part where he's backing up. And then he doesn't hit that 3 feet again. He just continues on towards the grass. So today was all just about being able to read a graph and what it told us about a scenario. Our scenario is just about a turtle walking out of the water to move towards the grass. So let's say one last thing about how does a point on a graph represent a part of the story, and let's give at least one example. We can say a point on the graph, on this graph, represents a location at one moment in time. A point on the graph represents a location. At one moment in time. At least that's what it is for this turtle scenario. And for example, it says give at least one example. Let's take the coordinate 26 from up here and talk about what that says about a moment in time for this turtle. If we read the graph, we could see that this first number represented seconds, and the second number represented the distance from the water in feet. So that coordinate, that point on the graph, says that the turtle is 6 feet from the water. After traveling for 20 seconds, or after walking for 20 seconds. So that's how a point on a graph represents part of the story. It just captures a moment in time. So you'll have some homework tonight where you'll do some interpreting of some graphs. Hope you enjoyed the turtle activity.